Hi everyone. In this video I am going to introduce some parameters like prime implicant, essential prime implicant, redundant prime implicant and selective prime implicants. These are not a special one, so these are already a part of the K-map which we have already seen in the previous videos. In the four variable K-map, let us consider a four variable K-map. Okay, now four variables A, B, C, D mapping with 00 gray code 0111 10 00 01 11 10. Now, for example, there are ones like this. We are having some ones like this. Okay, now first we always check for the maximum to minimum in the descending order. Maximum number of mapping is there that we need to do first. Here in this particular example, we have four ones we can map together first. These are four ones. Okay, and another thing is let us consider one more one here. These two can be mapped together like this. Okay, that means this is one group of ones and this is another group of ones. It is a bunch of minterms. It is also a bunch of minterms. From this bunch we can write one prime implicant. We can write one minterm that is called prime implicant. Okay, the group of ones, a bunch of ones will lead to an expression that is called as prime implicant. So for every K-map, the one which we are writing the expression, it is because of group of ones. It is because of group of ones. That group or bunch of ones will create a subcube. That is, the bunch is called as subcube. Okay, we'll write here. Each square or rectangle made up of or rectangle made up of the bunch of adjacent minterms. The bunch is nothing but group. Adjacent minterms is called a subcube. Suppose see here, it is the square. The mapping with four ones is in the shape of a square. The mapping with two ones is in the shape of a rectangle. That means it can either create a rectangle shape or it may be a square shape. So this particular part is nothing but a subcube. Each subcube is called a prime implicant. Each subcube is called a prime implicant. Each subcube is called a prime implicant. Hope you understand what I mean by prime implicant. So the mapping what we have done in the case of four variable K-map or three variable K-map, and in future in five variable K-map also we will do that. This particular mapping a group is nothing but a subcube. It is also known as a prime implicant. Now we are going to see an essential prime implicant. This is what a prime implicant. Prime implicant is nothing but a group of ones will create one set. Now what do you mean by essential prime implicant? Essential prime implicant is nothing but the prime implicant which contains at least one which cannot be covered by any other prime implicant. Which cannot be covered by any other prime implicant. Suppose I have one more one here. Okay, I have one more one here. See, this one is covered with only this particular one. Okay, this particular one minterm can cover with only this one, and this one is not able to cover with any other minterms. It can be covered with only one prime implicant. It cannot be covered with any other prime implicants. So this particular minterm is known as prime implicant is known as essential prime implicant. Essential prime implicant. Okay, so what do you mean by essential prime implicant? The prime implicant which contains at least one which cannot be covered by any other prime implicant is called essential prime implicant. It should be covered with one prime implicant, but this one cannot be covered with any other. Okay, suppose I have one more one here. I have one more one here in this last box. Then it could not be essential prime implicant. Okay, depends on the presence of adjacent ones. The name of the prime implicant will be varied as essential prime implicant, selective prime implicant, or redundant prime implicant. So in the heading also I told you prime implicant, essential prime implicant, redundant prime implicant, and selective prime implicant. These are different types of prime implicants, but origin of all these prime implicants is nothing but main prime implicant. Okay, first everything is a prime implicant, later depends on the adjacent ones, we call it as a essential prime implicant or redundant prime implicant or selective prime implicant. Okay, so I will write the definition here. Essential prime implicant, EPI, essential prime implicant is represented by EPI. So the prime implicant which contains at least one which cannot be covered by any other prime implicants is called an essential prime implicant. An essential prime implicant. Okay, EPI, essential prime implicant. Okay, now what do you mean by redundant prime implicant? Redundant prime implicant, RPI. Redundant prime implicant is nothing but RPI, redundant prime implicant. The name clearly tells that it is redundant. It is redundant. Suppose in one mapping, the ones are covered. Suppose still if you want to cover with the other adjacent one, I will show you the example. Without that you cannot explain. In the previous example also I can show that. Okay, 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Now for example, consider 4 ones like this, and one here, one here, one here, one here. Okay, now by seeing this, but first we will map these four because these four are at the center and they are adjacent together. So what do you mean by this? This is a prime implicant. Whether it is a redundant prime implicant, essential prime implicant, that we need to decide now. See here, this one need to be mapped. Where this one can be mapped? This one can be mapped with only this one. We don't have any other choice. So this one can be mapped with this one. And again, if you see this one doesn't have any adjacent cells except this, so that it can be mapped with this. And similarly, it can be mapped with this. And similarly, this one can be mapped with this. How many such events are there? Such prime implicants are there. 4 such prime implicants are there. But if you clearly see, this one can be mapped with only this one. We don't have any other adjacent ones to map. That's why this particular prime implicant is known as essential prime implicants. Let us mark each and every prime implicant in this example. This is also essential prime implicant. This is also essential prime implicant. And this is also essential prime implicant. Okay, these four are fine. Now, according to our heading, this is redundant prime implicant. Now, if you see all these four, all these ones, the blue color one, the blue color four ones which I have mapped in the beginning, those ones are covered by all these essential prime implicants. Clearly, listen clearly. These four ones at the center which I have mapped in the beginning, all these four ones are mapped already with all these four essential prime implicants. Is there any need of doing the same again? No need. Still, if you want to do that, that will become a redundant prime implicant. That is known as redundant prime implicant. Redundant prime implicant is the one in which the ones are already mapped with essential prime implicants. Still, if you are doing the same, that is nothing but redundancy, repeatancy. Okay, so that is known as redundance prime implicant. I will write the definition here. So the prime implicant, whose each one is covered at least by one EPI, at least by one EPI, essential prime implicant, is called a redundant prime implicant. Redundant prime implicant. Hope you understand what do you mean by redundant prime implicant. In the see here, all these four ones are mapped with essential prime implicants, but this mapping is particularly known as redundant prime implicant because it is already mapped. Okay. Now the last one is selective prime implicant. Next one, selective prime implicant. SPI. SPI means selective prime implicant. Selective prime implicant. Selective prime implicant is also a type of redundant prime implicant which can be taken or cannot be taken. Because, okay, for example, consider this example. A B C D 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Now, for example, F is equal to some ABCD summation of M of 0 4 5 10 11 13 and 15. Okay, one example is considered like this. Now map all these ones here. So 0 4 5 8 9 10 11 12 13, this is 15. Okay, now see here, all these are in zigzag fashion. L, again L shape, L shape, L shape, like this. Now how to map these? See, first we can map essential prime implicants, or we can map these two. Okay, and this we can map, or this we can map. We have a doubt. Okay, listen carefully. These two we can map like this, and these two we can map like this, and these two we can map like this. Okay, but this one can also be mapped with this one, and these two we can map separately. Okay, these two we can map separately. Okay, let us consider these two sets as separate sets, which we call it as essential prime implicant. Essential prime implicant here and here. Essential prime implicant. Two essential prime implicants are there. Now, I am explaining now what do you mean by selective prime implicant. In selective prime implicant, see, this one can be mapped with this one, and this one can be mapped with this one. This one can be mapped with this one, and similarly this one can be mapped with this one. Okay, take it as first for our convenience to understand, and take it as this one, vertical one, second, and take this as third, and take this as fourth. Okay, what do you mean by the first combination? First combination is 4 comma 5, isn't it? First combination is, see, this is 4 and this is 5. Okay, according to location I am writing 4 comma 5, and another set is, let us consider, see, this one is covered here. Okay, another set is third one, 15 and 11, 13 and 15, sorry, 13 and 15. This is 13 and this is 15, another set. And one combination is 1 and 3. One combination is 1 and 3, that is 4 comma 5 and 13 comma 15. We better take the K map. See, you have like this. First, these two are already mapped. These two are already mapped as essential prime implicants. Now, I am saying map these two as one set and map these two as another set. This is one possible set. So that's why it is 1 4 comma 5 and it is third 13 comma 15. This is one set we can take along with these two. Okay, total how many? 4 min terms are derived from this K map. Okay, this will be the first essential prime implicant, and this is the last essential prime implicant. These two are common. Along with these two, we can take these two. This is selective prime implicant. We can select these two. Or another combination is first set, and second set is, what do you mean by second set from this? See, 1 1 1 1 1 1 1. So these two, of course, these two are essential prime implicants. We are not disturbing them. And now 5 and 13. These two I have to take as another set. This is nothing but second one. And 13 and 15. These two. See, our selection, our mapping should select all the ones. No one should be left free. Okay. This is third one. So what is the mapping now? Second and third, that is 5 comma 13, and another set is 13 comma 15. 13 comma 15. The expression for this one, see, the expression for this one, first one is a b a bar b c bar plus abd. Okay, if you take a K map and simplify this, that you will get for these two, first one and third one. Okay, I will for example I will explain here. 0 1 1 1 1 0 0 0 0 1 1 1 1 0. See, for this a bar b and here it is c bar. This is first expression, and the second one is, for this one it is ab, and from cd it is d, abd. Okay, for first and third, this is the expression. And here for second and third, what is the expression for second one? Second one is vertical one. So here 0, 0, 0, 1, 1, 0, 1, 1. Sorry, 1, 1, 1, 0. So 1, 1 means A, B. B is common. And here it is C bar D. So A, B, D plus B, C bar D. This is the second one. And third selective prime implicant could be 5 comma 13 and 15 and 11. So the expression for this one is B C bar D plus A C D. Okay. See, from K map you can take it as A B C D 1 1 1. These two are essential prime implicants which are already mapped. Now what is our combination? 5 and 13. 5 comma 13 means this is 5, this is 13. This is one set which is 2 in our case, and this is another set which is 4 in our case. 4 means here. Okay, numbers. So what I have taken? Second and fourth. Second and fourth. The expression for this one is this one. B C bar D plus A C D. Hope you understand what I am explaining. See here, this is a selective prime implicant. Selective prime implicant means we can take this one or this one for mapping this one. And similarly, for mapping this particular one, we can take this mapping or this mapping. For mapping this particular one, we can take this mapping or this mapping. We cannot take both. Then it will become redundant prime implicant. Okay, we can select any one prime implicant. That's why it is known as selective prime implicant. Okay, so it may be either first case, second case, or third case. You can take any of these three cases, any one of these three cases, not all three. Okay, if you take all three, then it will become redundant prime implicants. Okay, so from first case, from first case, it is, the expression is f of a b c d is equal to a bar c bar d plus a b bar c. These two are essential prime implicants which are common in all the cases, plus a bar b c bar plus a b d. This is from first case. From second case, f is equal to, these two are common, a bar b, these two are common, plus b c bar d plus a b d. And from third case, f is equal to, first two are common, a bar c bar d plus a b bar c plus, what is the third case here? B C bar D plus A C D. Hope you understand. See, you can take either this one or this one or this one. These three are correct. You can take only one. So when you are going for the selection of a particular prime implicant, that is known as selective prime implicant. This is what? Prime implicant, essential prime implicant, selective prime implicant, and redundant prime implicant. Thank you.